Remember, we worked on this table, okay? This table, okay? Okay, the starting point is 0, right? Which is the mean, okay? Which is the mean, remember, okay? So, this time by using this table, we try to figure out, okay? For example, z-score, raw score, probability under the curve. Does it make sense? Which in turn leads to statistical inferences. Okay? Statistical inferences. Okay? So it's very important for you guys to understand, okay, how to figure out probabilities under a certain curve. With me so far? And then, I want to say this upfront, okay? Not for just exam purposes, but also for, for your understanding. Always draw a diagram, the way I do, okay? You'd like to jot down. Always draw a diagram for each single question I asked you, okay? It's not just for the exam, but I myself do it. With me so far? I myself do draw a diagram to figure out, those things, okay? So for each single question, draw a diagram. With me so far? Okay. Now, I want you guys to take a look at the statistics 1 handout, okay? On page 9, okay? We are going to do, okay, those questions together. How about that? With me so far? Okay. Okay, so the question is this, okay? Final exam scores are normally distributed, right? Normally distributed. So we are talking about the normal distribution, okay? We talked about the 5 characteristics of normal distribution, remember? Okay, we talked about it, right? Okay. And then, what is mu? The mean of the population, excellent. Then, Claire?
The mean of the sample.
Very good. Sample? Sigma.
That's population.
Yeah.
Oh, that's population.
Yeah.
Yes.
The
Sorry.
population.
Sorry. Yeah.
Yeah. Okay? So this is the standard deviation of the population,
Population.
right?
What Greek letter is that? Is that an A or an S? Under the mu, which Greek letter is that?
Oh, this is called mu.
Yeah, below that.
Oh, below that, sigma.
That's your sigma.
Uh-huh, sigma, right? This is called mu, and this is called sigma. With me so far? Both are lower cases. Lower cases, okay? Okay, about notations, briefly, please take a look at the page 1. Page 1, okay? Do you see that? All right. Okay, this is the list of notations, okay? Signs, right? Okay, so let's go back to page 9. So, again, final exam scores are normally distributed. The mu, which is the population mean, is 70. Okay? The sigma, which is the population's standard deviation, is 5. Okay? We are dealing with individual values in the population distribution. Okay? So, you have to draw a diagram, okay? Diagram for each single question. Okay, that's what we are going to do. Okay, that's what we are going to do. Okay, so number one. What's the probability of a randomly selected student having a score between 75 and 80? With me so far? Okay. One of the things I don't want you guys to do is to calibrate. Okay? Calibrate the normal curve. Like, okay, the mean is 70. Okay? So, one standard deviation above it is 75. And then 80. I don't want you guys to do that. Okay? The reason is that what if sigma is 5.4672? How do you calibrate? Right? Do you understand what I'm getting at? So please do not calibrate. Okay? The normal curve. Okay? You don't need it. You do not need it. With me so far? Okay. Okay, so let's go back to this question. So what's the probability of a randomly selected student having a score between 75 and 80, right? Am I correct? Okay, the first thing you have to do right? Okay? You have to draw two straight lines. Okay? And then the curve, right? The normal curve. Everyone knows the shape. With me so far? Okay. Now, then the second thing you have to do is to plot, the mean. With me so far? For the x score, the mean is what? 70, exactly. You can speak up. Okay?
Say it loud, girl. 70.
70, exactly. Then, let me ask you, what's the mean of the z-score? Standardized normal distribution. What's the mean? 0, exactly. Very good. Excellent. Right? That's what we learned, remember? Under the standardized normal distribution, the mean is always 0. The standard deviation is always 1. Remember that? Okay? 5 characteristics of the normal curve. You have to understand that completely. With me so far? Okay? Okay? This is the first thing you have to do. With me so far? And then look at the question. Okay? We want to find a probability, okay, between 75 and 80. Am I correct? Right? Okay, so given that the mean is 70, okay, 75 is on the right hand side or left hand side? Right, exactly. Am I correct? What about 80? Right or left? Exactly. Right? Am I correct? Okay. With me so far? Okay, so graphically, this is the area of probability you are looking for. Graphically. Do you understand that? Okay. So, this is the normal curve of final exam scores, right? Final exam scores. Final exam scores are X, right? With me so far? Right? Bunch of X's, right? Some people got, I don't know, 60, 40, 1, I don't know. That would be horrible. Okay, other people got 75, 80, 90. 95, 98, I don't know. Does it make sense? So the whole point I'm making here is that this is the distribution, okay, called standardized normal distribution of final exam scores, right? Namely, X scores. With me so far? X scores. Okay. Now, having said that, we are looking at this area, okay? The probability associated with this area. Am I correct? Am I correct? Then, what's the next step? Intuitively, what's the next step? We know 75 and 80, right? Can we directly calculate the probability? Is it possible?
Do you need to find the z-score?
Exactly. Very good. We have to find the z-scores, right? Do you see that? Why do you think we have to find the z-scores?
To find the probability,
Yeah,
because it'll be equal, or you can find.
right, we can use this.
Yeah.
Am I correct? This is a table for, okay? This is a table for probabilities associated with, okay, each z-score, ranging from 0 to whatever z-score. Am I correct? On the right-hand side, positive side only. With me so far? Okay? This is the standardized normal distribution. With me so far? That's why once we know z-scores, we can calculate probabilities easily. Right? With me so far? Okay, now, why don't we calculate z-scores? Okay? When x is 75, how can you calculate z-scores? The z-score for this? Anyone?
75 minus.
Who said that? Excellent.
Jasmine over there.
Excellent.
Minus 70 over 5.
Exactly. Excellent. Awesome. 75 minus 70 over 5. Right? The reason is simple. We talked about this. Remember? That's z-score. Remember this? Right? Z equals, okay, deviation score divided by the standard deviation of a distribution. Remember that? Okay? Very good. Very good. So 5 over 5 equals, huh? 5 over 5 equals 1, exactly. Excellent. Right? Then what about the other one? When x equals 80. Someone else. Someone else.
80 minus 70 over 5.
80 minus 70 over 5 equals 10 over 5 equals
2.
exactly. With me so far? Now we can plot z-scores here. Do you agree? Right? So plus 1 here, plus 2 here. Right? Okay? Plus 1 here and plus 2 here. With me so far? Now from here, we have to use this. Am I correct? Okay. Okay. Let me use this area. Okay. What can we know from this table? Given that we identified the two z-scores, what can we know regarding probabilities?
Rows.
Huh?
Rows and
Speak up.
column. Rows and column.
Okay. So z-scores are, column and row, right? And then inside, you can see probabilities, right? So, intuitively, what do you have to do first? to identify the probability of what?
1 and 2?
1 and 2, that's the final solution, right? That's the final solution we have to have. But in order to reach that, what do we have to do? Huh? Add? Okay. So add meaning what?
Summation.
Okay. What Claire said is correct. We would like to know the probability between 1 and 2. Am I correct? We can't directly get that from this table. Why can't we get directly? Why can't we? Why is it impossible for us to get the probability, okay, between 1 and 2 directly from this table? Think about the nature of this table.
This is the distance from the mean?
Exactly. Excellent. The starting point is 0, right? Exactly. The starting point is 0. Whatever probabilities you see, okay? The starting point is 0. And this side, right? So how can you possibly find this probability directly? It's impossible, right? Very good. Do you understand what I'm getting at?
Nope.
Okay. This table starts with 0. Remember?
Yep.
Remember? Okay. All probabilities are associated with z-scores between 0 and something on the positive side. With me so far. Okay. Then, do you understand that it's impossible for us to find out this probability directly from this table only in one shot? Conversely, can we identify a probability just looking at this table? It's impossible, right? Because again, all probabilities start with 0. Right? We have to do some arithmetic. Do you understand that? With me so far? Okay? Having said that, what's the next step?
Could you find like 1 and 2 on here and then do something with those two numbers? Is that right?
Okay, elaborate what you said.
Like find
Find
the
the probability between
0 and 1.
0 and 1. Exactly. Excellent. Exactly.
And then do you find it for 2 with 0 and 2?
Exactly. I'm sorry I didn't tell you the answer because it's important for you to figure out by yourself. Does it make sense? I could have given you an answer easily, but that doesn't help you learn the whole process. With me so far? Again, one of the most important things is that all probabilities start with 0, z-score of 0. With me so far? That's why it's impossible for us to figure out this probability directly from this table. With me so far? Is everyone clear about that? Okay, very good, excellent. Exactly, right? Then the second probability is, of course, exactly. Why don't we find those two probabilities, right? Okay, the first one. The probability between 0 and 1, okay? The probability under the curve of z-scores between 0 and 1. The answer is? Oh, this means probability, P. You guys understood, right? Okay? Anyone?
0.3413.
0.3413. Did you get that? How many of you got that? Excellent. Excellent. Exactly. You guys got that, right? Okay, very good. Excellent. Now the next one. The probability under the curve between 0 and 2.
0.4772.
Huh?
4772?
Exactly. Excellent. Excellent, you guys. Excellent. 0.4772, right? Now it's the time for us to look at this diagram. Right? Okay? Am I correct? Am I correct? Okay, between 0 and 2, 0.4772. With me so far. And then between 0 and 1, this is 0.3413. Now here's a question. Should we add or should we subtract? Subtract. Very good, subtract. With me so far? Because we are looking for the leftover, am I correct? That's why it's important for you guys to actually draw a diagram. Even I do. With me so far, even I do. Otherwise, I couldn't calculate the probability. No. Right? Because by graphically drawing a diagram, I mean, it's real that time, sorry. By drawing a diagram, you can easily find, right? Okay, so what you are looking for is this area, the probability between 1 and 2. Am I correct? That's the graph. Okay, that's what this graph is showing to you. With me so far, right? Now, here's one more thing. Which way should we subtract? From this one or from this one? From, yeah, exactly. Very good. Right? What's the answer?
1359.
Point
1359.
1359? Exactly. Excellent. That's the answer. Right? And then the question says, what's the probability of a randomly selected student having a score between 75 and 80? The answer is 0.13559. That's the probability. Okay? If you convert this into percentage, it should be 13.59%. With me so far? 13.59%. That's the answer. With me so far? One more thing. Am I correct? Am I correct?
What's your right? Oh, you did the other way.
Everyone said no. Thank you. Exactly. Probability never.
It's not negative.
Exactly.
I do remember that much.
Excellent. Excellent. Probabilities will never become never become negative, right? Exactly. Then you obviously made a mistake here, right? With me so far? That's excellent because z-scores can be negative. Remember, depending on whether a particular z-score is below the mean or above the mean. Okay? This table only shows the positive side. Okay? Because it's symmetrical, right? We don't need another table. It's simply symmetrical. Okay? All we have to do is to change signs, plus or minus. With me so far? But again, probabilities never, okay, will never become negative. Besides, this diagram clearly shows, right, what you are looking for here. With me so far? So this part. Doesn't sound bad, right?
No.
Not at all, right?
So you have to do it.
It's not here, yeah.
But in here,
Till we
no.
test.
This is a safe spot, a safe room.
Okay, very good. We are going to make a progress, right? Okay? So on page 9, okay, the first one, z equals, okay, z equals plus 1, right? Okay, z equals plus 1, right? And then the area under the normal curve from z equals 0 and 1. 0 and 1 is 0.3413. With me so far. And then, right? Okay? I am talking about the first line with 3 blanks. With me so far? With 4 blanks, I'm sorry. Z equals plus 1, right? The area under the normal curve from z equals 0 and 1 is this 0.3413. With me so far. And then the second line with a bunch of blanks, okay? The z-score equals plus 2, okay? Plus 2. The area under the normal curve from z equals 0 and 2 equals 0.4772, right? Therefore, the answer is, this one is the answer. With me so far. Okay? Okay? Now, can we go to the next question?